If you look at that table right there, this is a rough sketch of it graphed out. That's what that function is going to look like, right? So you could use a picture. If you can graph it out, you can determine which part's the steepest. It's not always going to be crystal clear, so I would recommend just using algebra over here on the table. But if you can graph it out, it looks like it's pretty steep between this point to this point, which would be representing 0 to 3 on the x-axis, right? I'm not going over very far at all. So 0 to 3, very steep line there. Okay, then it seems like my next section is a little less steep. But right here, I'm looking at which line's my steepest. It sure appears it's going to be from 0 to 3, my first section of that function. So that's how you just represent it on a picture, a graph, right? Which is the steepest line? That would have the greatest average rate of change. But if you want to solve that algebraically, let me break that down for you in the table. Is we've got to figure out what's my average rate of change between 0 to 3. So I'm growing by 3 on the x values, but my y values, something significantly different's happening. And we can clearly see that these numbers are not growing by the same amount every time. So it's not linear. It's going to have curvature like you see in the graph. So 8 to 64, I'm going up a total of 56. Now what I need to do is I got to find my change in y over my change in x. You've heard that before. So grab a calculator, run through these quickly, and figure out what change in y over change in x is for each one of these sections going down. We call those sections intervals. So I don't have the word interval up there. Okay, so change in y over change in x is going to give you your average rate of change between 0 to 3 in this case. So 56 over 3. 56 over 3, and then you just say what that comes out to. Now, what I would highly recommend is you keep nice, good, clean, organized work so that you can just look at this number, this number, this number, and this number. Find the one that has the largest value. That's going to be your answer here. So 56 divided by 3. That's going to leave me with 18.6 repeating. Okay, that's a pretty steep line. That'd be that first section like we talked about, right? Very, very steep line right there at the beginning. Okay, and then I got to figure out 64 to 118, 3 to 7. I want to write down how much I'm growing here by how much I'm growing there. That's going to leave you with 54. Over here, 3 to 7, definitely should be able to do that mentally. 3 to 7, add 4. 54 over 4. 54 over 4. I'm hoping it's either greater than or less than this value. If it's greater than, then this becomes the one so far. 54 divided by 4, 13 and a half. Right away, I can tell you that the average rate of change between 3 to 7 is less than the average rate of change between 0 to 3. We can tell on our graph over here because remember the second line I drew, not nearly as steep. Okay, 118 to 146, that's 28. 7 to 21 is plus 14. Take 28 over 14. Those numbers have something special about them. That's going to come out to 2. Okay, 28 is double 14. And then last but not least, you're left with 34, 21 to 32, that's going to be plus 11. 34 over 11 should be a little bit bigger than 2. 34 over 11 equals 3.09 repeating. So if you were asked to put them in order, you could put them in order. In this case, we're being asked the greatest. So 2, 3, 13, 18, boom. There's your answer. So how do you give your answer? You're going to say x equals 0 to x equals 3. In the interval of x equals 0 to x equals 3, we have the greatest average rate of change. I hope that makes sense. All you got to do is just use those tables.